Today, we are going to discuss logistic regression by Python. You should see my earlier videos, logistic regression by SPSS and logistic regression by eViews. Now, what is OLS? Now, in the OLS regression, we simply take y is equal to a plus bx plus error. Now, where y is equal to 0 and 1. Now, I just want to give you one example. Say, a is minus 0.3 and b is 1.5. Now, if x is equal to 1, so what will happen? 1.5 minus 0.3 is equal to 1.2. It is more than 1. 1.5 minus 0.3. The y is equal to more than 1. What do you mean by more than 1? That it is expecting the probability is more than 100%. Similarly, if x is 0, so then in that case, the y is equal to minus 0.3. Next one is the error terms are heteroscedastic. That the variances, they do not remain constant throughout, they change. E is not error. Error is not normally distributed because y takes on only 2 values. The predicted probabilities can be greater than 1 or less than 1, as I have given you the example. Say a is minus 0.3 and x is 1.5. So it will be, if x is 1, it will be more than 1. Y will be more than 1. If x is 0, y will be less than 0. So that does not look nice. That does not look good. So that is why we don't use linear probability model. Now, this linear probability model, if I show it on graph, the graph will become your x variable here. The graph will become like that. It will cross 1 or it will cross 0. So this probability will be crossing more than 1 or less than 0 in case of linear probability. So there is a fatal flaw, OLS, least square method. Logistic regression, basically, we talk in terms of probability. So model is like that. ln, that is log. ln is to the base e. Log is always taken as base 10, but we usually take ln. So in softwares, it is easy for us to anti-log. Anti-log is exponential term. So ln is of p upon 1 minus p. So what is p? P means probability divided by 1 minus p. So this actually, this is called odds. How many odds we have got? So p upon 1 minus p. And if we take the log of that, and then we regress it on x with alpha plus beta x plus error. So then it will be a good thing. The probability that events y occurs, and p upon 1 minus p is the odds ratio. So log of odd ratio, we may call it Logit. We may call it Logit. So log p upon 1 minus p. Now, in that case, if we compare the linear programming and Logit model, so as I have already explained, this will cross these two lines, 0 and 1. This LP model, linear programming model, will cross 0 and 1. This is though we don't want it. But Logit model, that will remain within the 0 and 1. That is the benefit of Logit model, because it will not cross the 0 and 1 lines. It will remain within the 0 and 1. Here you can see the file where I have taken 3 independent variables: age, income, debt, income ratio.
and default. The person has taken the loan, whether with these variables, whether he is going to default or not. If he has defaulted, it is 1. If he has not defaulted, it is. Now you see, it's a very simple 2 lines commands for logistic regression. I have already started Anaconda and the editor Jupyter. The simple commands are, if you want to just add constant to this regression, you can write down x sm.add constant x, which we have already done in multiple regression. And this is the basic command log regress. Just I have created one variable. You can write down anything log, you can write down reg, you can lr. This is just a simple variable. There is no problem. And your main command is sm.Logit yx fit. Now y should be binary. It should be 0 or 1. And x, there are a number of independent variables. You can take 1 variable, you can take 2 variables, you can take 3 variables. All other commands we are going to take up from my earlier video. Just copy it, paste it, practice. We are to import many functional packages, which we have already done in multiple regression. After importing it, we will open the file, database file, and then after opening, we will select it. Then we will select the variables for y and variables for the x. And then simply we will run this command. I am going to copy and paste the functional packages which we need for this purpose, which we have already done in earlier videos. See, we have built on the commands one on the other. Should start from video 1. We started with simple commands. Then we went on adding. In video number 11, 12, we started how to open the file instead of writing the file name. Pandas will read the file. Let us copy. See, import Tinker as TK. This will help us to browse the folders. Import Pandas as PD. We don't need maths at this time in this package, but I have just written it in case if we need to make some round up or something else. We have just imported the math. Seaborn SNS, we have to do certain visualizations or some other things, then we can use this. NumPy as NP. Matplotlib.pyplot as PLT. We don't need this. These 4 commands, 5 commands, we don't need it. But I have written it in case you want to add something, to do something more. Then stats model, you have to import SM as SM. Then stats model API as SMA. Then import, now this one, there is no need for this. And these also are not required. You can just say bye-bye to them. There is no need. I've just written. Because we have already done this one, so there is no need for this. So we can say import TK, enter as TK, import Pandas. These are also not required. There is no need for this, but we have written it. Import math, Seaborn SNS, import NumPy as NP, Matplotlib, pyplot, SkyPy, import stats model. Now stats model, we don't need OLS. There is no need for OLS because we are not going to do ordinary least square. We are going to do logistic. But we need this sklearn linear model import logistic. This we need. But this we also need it in our next one when we are going to test, train and all. Machine learning. Now all these commands you have already worked on with multiple regressions. You are going to count the columns in the database. And then you have to select which one is going to be your First one, choice for y. It should be binary. It should be binary. It should be binary. Binary means 0 or 1. Then whatever your input is there, that is converted into your column number and then column, and then y will be your DFC. That is C, whatever you are there, that will be your y. Then you are going to create an empty array, and then that you will put 1, 2, 3, 4 as your dependent variable, your choice for independent variables, independent variable. Separated by commas, then it will create a list, and this list will be entered into a sample file, which will be your df file, and df, say with that, it will take it from df and it will become the df1, which will be the sample, and this will be transport, and from that the columns will be taken up. So now these commands are important for taking the x variable. So x is df1. Next, we have to simply write down the commands. Now we have got x, we have got y. These commands, whatever we have written it up, we will just copy it and work on. See, I have written x. If you want to add constant, there is no need to add constant. Sometimes we work without constant. Then this logreg, it is just a variable. You can take any name. You can say write down LG, you can write down simply RE, RP, sm.Logit. This is our main logit. Y should be your binary x, and it will fit, and it will run the summary. Let us run it. I'm going to select the file, my test 12, which I have shown you, default. So my choice for y is number 4, default. And my choice for others are 1, 2, age, income, and debt income ratio. Now this is all calculations done for you, logistic. See, number of observations are 499. We have lost 4 degrees of freedom. Why? Because there are 3, age, income, and debt. There are 3 variables and 1 is constant. So 4. So we have lost 4 degrees of freedom. So degree of freedoms of residuals are 495. Pseudo R square is used in place of this R square. So now this. Now we want to calculate the probabilities of all our database. So I'm just going to write down 2-3 more lines just to calculate the probabilities, and it will also tell me if it is probability is more than 0.5, it will say 1. If it is less than 0.5, it will say 0 automatically. So I'm going to write, and then both the files df3 and df1, here df1, for which we have taken it up, that will be merged. And you can see that database 4. I'll just run it. Test 12. My dependent variable is 4, that is default. All other 1, 2, 3 are my. So now this is calculated. See how this probability has been calculated. Just see the excerpts of my earlier video. I can use the forecast. Using these outputs, I can forecast. Say the age of the person is say 50 years. Income is say 120. Debt income ratio is say 8. And constant is naturally is going to be 1. So will this person default? What is the probability that this person will default? Let us see now. This ln
P upon 1 minus P. This is the log of your odds. Log of your odds. This is equal to sum product of what? Sum product of these. These are the coefficients, and then now actual values you want to predict with the actual values. What are the actual values? So now this one is your log of, what is actually this? A plus 0.05 minus 0.051 into age plus 0.005 into income plus 0.133 into debt income ratio and minus 1.015 into constant. Okay, now we are going to take anti-log of this. We are going to take anti-log of this, exp of this number. This will give me anti-log, and then I will take it up the values of this. This value is equal to B12 divided by B12 plus 1. See how I am going to use this formula. Say probability is equal to this one. Probability is equal to 1 minus P. This way I can take it as this. I can take it as probability is 1 minus P into X is equal to this. I can take it as X. Probability is 1 upon minus 1 minus P is X. So P is equal to 1 minus P into raised to into X. So P is equal to X minus P. So this P, this also I will take it up the same. P plus X, P is equal to X. So P into 1 plus X is equal to X. So P is equal to X upon 1 plus X. So that is why I am going to use this formula. B12 upon B12 plus 1. B12 plus 1. Okay. So this gives me the probability. Probability is 0.12. So this means 12%.
See, I have written these commands df3 pd data frame prob this, and I am going to merge this with df. I am going to merge this with the main file, and it will give me the probability. I'll say run 12 so it will be 4 1 comma 2 and it is giving me the main file A's income debt income ratio default prob predict. Now this probability, if it is less than 0.5, it is giving prediction label is 0, but actually he has defaulted. Now here in the second case, the person has not defaulted, but our prediction says 1. So how much it is correct or how much it is not correct, the accuracy we will see in the next video. But I want to see all the entries. So what I will do, I will export this df4 to my folder as an Excel file so that I may see it later on. Let us write the command. So I have written it here, df4 to Excel file. This is my path name, and I will run it again. Now this, let us see, 12 open. This one is 4 1 comma 2. Just see in my folder Python 3, and here my jks2 file is there. I will open it. This file has been. So now this is A's income debt income ratio default, and this is the new probability which we have created and new prediction label which we have created. See, Here in the first case, it is 1, 0. Predicted is 0, but actually it is 1 because the probability is 0.2. How the model is accurate, that we will see in our next video. We'll calculate the accuracy. Thanks for watching.